In this video, there is a frustum which is of height h and mass m, and the radius of its lower surface is 2r and its upper surface has a radius r. You can see that this frustum is formed by removing a smaller cone from a bigger cone. So we have to find out the moment of inertia of this frustum about this axis, which is passing through the center of mass of the frustum, as well as which is also perpendicular to both the bases. Now we know that this frustum is formed by removing a smaller cone from the bigger cone. So if we assume that this is the bigger cone, this one, and the radius of this bigger cone, the base radius is 2r and its height is 2h. Okay, so the moment of inertia of this bigger cone about this axis is I1, and I1 is equal to 3 by 10 m dash, where I have assumed that mass of this bigger cone is m dash and its radius is 2r whole square. So I1 is equal to 3 by 10 m dash into 4r square. Now first of all, let us draw the smaller cone. So this is the smaller cone which we have removed, and it has a base radius of r. Now its moment of inertia about this axis is I2, and therefore I2 is 3 by 10. Now mass of this smaller cone would be m dash by 8, because it is having a half radius as compared to the bigger cone, as well as its height is also half. So the complete mass of the cone, solid cone, is distributed on its volume, and therefore the volume of the smaller cone is 1 by 8 times of the volume of the bigger cone, and therefore we can say that mass of the smaller cone would be 1 by 8 times to the mass of the bigger cone. So if mass of the bigger cone, I have assumed it is m dash, then the mass of this smaller cone would be m dash by 8 and its radius is r. So this is r square. So I2 is equal to 3 by 80 m dash r square, and m dash can be calculated by the fact that this mass m is equal to m dash minus m dash by 8. So m is equal to 7 m dash by 8, and therefore m dash is equal to 8 m by 7. So this is m dash. Now I2 is equal to 3 by 80 into m dash, which is 8 m by 7 into r square. So I2 is equal to 3 m r square by 70. So this is the moment of inertia of this smaller cone about the same axis. Now obviously this frustum is formed by removing this smaller cone from the bigger cone, and therefore the moment of inertia of the frustum can be written as I1 minus I2. So I frustum is equal to I1, which is 3 by 10 m dash into 4r square, and let me put the value of m dash. So I1 is equal to 3 by 10 and m dash, in fact 3 by 40, in fact 12 by 10. So 12 by 10 and m dash is equal to 8 m by 7 into r square. So this would be 96 m r square by 70, and this is 96 m r square by 70 minus I2. where I2 is 3 mr square by 70. 3 mr square by 70. So I of Frustum is equal to 93 by 70 mr square. So this is the correct answer. Thank you.